Okay, awesome. Thank you for joining me today. Just really quickly, housekeeping, this is talking about continuous monitoring and benefits for all stakeholders. So if you don't need to be here, you can sneak out without it being rude at all. And then second little housekeeping item, it's probably only going to be about 20 minutes or so. So please feel free to ask questions anytime. Raise your hand, I don't care. And obviously there's going to be lots of time at the end for questions as well. So quick introduction, my name is Caitlan. I'm with Qube Technologies. I will tell you a bit more about Qube, but just briefly for myself, I joined the company in January of last year and actually kind of dipped my toe into the emission side of things for the first time ever. I have seen things evolve dramatically, even from that point forward. And so I'll be speaking to you just from a perspective of what I've seen, even over the last kind of 15 months or so. Background in upstream technology and been in the oil and gas space for the last, 10, 15 years. So quick overview about Qube as a whole. We have offices in Calgary, which is where we're headquartered, but our main office and kind of primary deployment base is in the United States, and our office there is Houston. So we've just opened an office or a warehouse in Midland, Texas. And so that way we can actually kind of serve our Permian deployments quite a bit more. Very well funded. The name of the game, as you know, with most continuous monitoring technologies is detect, localize, and quantify. Qube specifically is a fixed sensor technology company. So we use fixed sensors on things like fence line or mounted posts to be able to monitor for greenhouse gases. Methane is the most popular and kind of primary, but we do offer other sensors as well, and in combination. Deployed in places like Bahrain, Oman, Saudi Arabia, Australia, northern British Columbia, and then every basin in the US. So when we're talking about exposure to all the environmental conditions that Earth has to offer, we've been exposed and we understand. Same device we deploy to Australia and Indonesia is the same device that goes into northern British Columbia. 55 plus companies and counting, and then saw a huge growth trajectory in 2022 that's continued on to 2023. And that number, I think, speaks volumes for us, but not only that, speaks volumes for the interest and the kind of transition to continuous monitoring in the industry as a whole. We are the at least first, if not only company in North America that's approved as an alternative for continuous monitoring technology, which means it's with the Alberta Energy Regulator in Canada. But what that means is the Alberta Energy Regulator saw our technology as good as or better than the current requirements and framework in place. So we are an alternative. Brief overview of us in a 30,000-foot view. We have a piece of hardware that we refer to as an Axon device or a Qube, and that's the device that has an anemometer on every single device so that we're monitoring things like wind speed, wind direction, all of our various gas sensors. It's battery powered with a solar panel recharge. We're collecting data every 1 second, gas concentration data as well as all the others, pushing it into our analytics platform. And then rather than you getting inundated with 1 second, every second worth of data, we're distributing it to you in a platform that allows you to actually interrogate and understand it without getting lost in the details.
How long does the battery last?
The battery lasts for if the solar panel was no longer there for any reason. In good conditions, it's probably like 8 days. I've seen it last 5, I've seen it last 14, but probably a good average is about 8 days if the solar panel is broken for whatever reason. Sorry?
Or borrowed?
Right. Or permanently borrowed with no intent of return. That has been an issue. I don't know how to hit play on this, but that's okay because I think the video moves too fast. This is basically a rapid fire training for what our dashboard looks like. The intent is to make it very user friendly and intuitive. So what you see on here, actually, let me just see if I can push play. What you see on here is our dashboard. This is the site that we're monitoring. It's a very simple digital twin rendering of what an actual site would look like. We have the ability to layer on a satellite image as well as drone images if you want those stitched in. But what we're showing you is basically a layout of the site. The colored dots that you see are the devices themselves that are on site to monitor. And then we have the ability to customize the window of time that you want to look at various data that we're taking. So kind of standard 24-hour, 7-day, 30-day, and then whatever custom time frame you want. This graph that you see at the top right here is a site rate. So it's not just ppms or gas concentration. We're actually generating a site rate graph for you as well. And so with people looking at various emissions events, if there is something on a low wind day that's a small leak, if you're looking at gas concentration only, you're going to think that there's a bigger leak than there is just looking at gas concentrations. Alternatively, there could be a very high leak or a high leak going on a high wind day that the gas concentrations wouldn't register as being very big because the wind is distributing it. So that's why we think site rate is really, really important. We also monitor things like gas concentration at the bottom, wind speed that you can see. And so this basically lets you know on a per piece of equipment basis, what's my biggest offender? Is it tanks? Is it separators? Is it flares? Is it VRUs? I can hover over a particular equipment group and it highlights for me all the various emissions events associated with that. I can also set alerts that vary based on whatever is specific to my site that should be deemed or dictated an alert. And I could go on and on about that. We're here for that. So before I get into the kind of benefits with stakeholders, I do always like to level set with everybody. I think this is sort of, ad nauseum. You've heard this, everybody in the room probably knows this, but I do like to kind of level set. Emissions reduction is definitely a priority, and we've kind of broken down 4 large categories of what problems operators are facing today. So kind of at the forefront of everyone's mind is increased government regulations and practices. I don't need to reiterate all of the various Quado, BC, emissions regulatory rules that have been proposed and will soon be finalized. But aside from all of these regulations and practices, and prior to them, there was a huge kind of industry push with investors and kind of the market sentiment and public sentiment in general to be able to look at a showing of an emissions reduction report, a sustainability report. And then there's also a big push for transparent and verifiable data to be able to say, yes, I'm producing kind of a reduction in emissions, but here's the data that you can look at to prove it. Here's kind of empirical evidence of my emissions reduction. And then obviously, if you're leaking gas, you're not selling it. If you're not selling it, that's foregone money. And then last but not least, there is incumbent technology that does exist. You've got your AVO, your OGI cameras, your MECA 21 sensors, and then your everyone's favorite greenhouse gas emissions factors, which are wrong, but they're kind of the industry accepted sort of baseline measurements. And so all of this to say there is an opportunity for technology in the space to come in and kind of help enhance what currently exists with the environmental conditions that you guys are facing from a regulatory and public sentiment perspective. So kind of the meat of it. Who are the stakeholders that we serve? We fully understand that there are kind of a distribution of categories of people that are interested in our technology. So first is the LDAR techs, your operations team. These are kind of the core folks that if they don't agree with the system that we're using, if they don't agree with which system's been chosen, how it's being administered, it's not going to take off and it's not going to be effective given the investment that you're making. The job of these folks is to make sure that emissions alarms are responded to, that there are not emissions leaking if they're aware of them, and that fixes can be found quickly. The kind of middle group of folks are, I say emission specialists and engineers, your asset managers. These are the folks whose job it is to balance asset performance with various targets and continue to make sure that production is at an all-time high while capital can continue to be invested in this asset attractively within the company. And so they're kind of where everything sort of comes together to make sure that an asset can continue to thrive. And then last but not least is the executive team. So these guys, these males or females, are responsible for setting the kind of goals or the North Star of a company. And everything else that folks do is because of what a strategic goal is for a particular year. And so a lot of times we will see companies that set emissions reduction targets and have the executive team be able to say, this is what we're heading for, this is why we're doing it, now you go and do it. And the most improvement, first we have to know what we're dealing with, and then we have to know how to reduce it. And if we have those types of targets at the executive level, that really helps. Other things that the executive team are interested in are various overall trends, understanding various correlations between different metrics like your GHG emissions factors and other sources of data, and trying to get an understanding and a threshold of where those differ and how to squeeze them kind of into a closer range. So early detection. This is kind of a simplified graph, but the intent here is to show the basic idea that if you found that the leak was detected and you responded to it in the same duration of time using a typical LDAR cycle or using a continuous monitoring technology, the amount of emissions that you would reduce is dramatically impacted by the usage of emissions technology. So what's showing in the blue triangle is basically that a leak is occurring, and because of continuous monitoring technology in place, you're able to become aware of that leak immediately. If you're aware of it immediately, then you can respond to it within a very quick time frame, thus reducing the emissions. If you become aware of that leak only on a typical LR cycle, whether that be monthly, quarterly, bi-monthly, annually, whatever it is, there's a huge potential impact for that leak to persist, whether it's intermittent and kind of continues happening, or if it's a continuous fugitive leak. And that pink shading on that graph basically is showing you the potential huge impact of letting that leak persist without fixing it immediately. And so for us, this is just kind of a good simplified realization that, yes, inherently being aware of a leak when it happens will make a huge impact on emissions reduction. Something that we do emphasize, though, especially for groups that are really starting out trying technology like this, is you have to get a baseline understanding of what's happening before the responses start to be quick and efficient. But technology like ours does not reduce emissions by itself. It's the response of the teams that do something about it that actually do the emissions reduction. We provide you with the data that makes you able to respond to it.
What constitutes a leak detection? Is it any like non-zero number, or do you have a certain threshold, like the detection limit? Or
yeah, so there are various definitions depending on what perspective you're looking at. So the EPA might define, like for instance, continuous monitoring technology to be capable of measuring something down to a 1.2 or 1.6 kilogram per hour level. There are certain limits that, depending on the size of it, you have a certain number of days to respond to it. But companies themselves will get our technology, do a first month baseline to say, what are we even working with? What are the emissions that we have? And then say, what should our particular threshold be based on this site? Because if we're operating in the DJ Basin and the Permian and the Bakken, those have totally different thresholds, right? And so companies can say, let me start out, so we don't get alarm fatigue. Let me start out with a high threshold, hit the really big ones that can make a big impact, and then work my way down once I get an understanding or a correlation of the emissions relative to various operational activities. And in that way, companies can set their own and then work them down. And that becomes kind of a metric that you can present back to internal stakeholders that are interested in progress, which is, here's how big our metric was at the beginning for a really long duration of time. Here's how small it is now because we've got such a good handle on various emissions.
what's the detection threshold, the sensor itself?
Good question. So for Qube, we calibrate sensors in-house down to a 1 part per million accuracy. And then when we deploy the devices to the field, we have a minimum detection limit of 0.1 kilograms per hour, which is great, but that's a minimum detection limit. So full transparency, that means in the best conditions possible. The leak in the gas plume, formed in such a way that the wind was blowing perfectly and the device was perfectly located. A standard or 90% probability is 1 kilogram per hour. So well under any threshold of proposed regulations. And that data has been verified and vetted academically and independently so that I'm not just saying it to you. It's in white papers and studies. Thank you for your questions.
Thank you.
So this is an example of the chart that I was going to show you, or that I showed you in the prior slide. So this feels like a million years ago. It was December of 2021. I can't believe it's 2023 and well into it. But what happened here was we had a client that was piloting a couple of continuous monitoring technologies. And this is an ideal but not ideal situation where they actually had a blown feed patch on the particular site that we were monitoring. And so you can see how quickly and dramatically a leak spiked with a blown feed patch. And that is something that could have potentially gone unknown for, a day if someone's not going to go out and visit it and kind of see it, but that's something that's big and can persist. Because of our technology out there, they were able to find out immediately that there was a really big leak occurring, send someone out to verify that something was happening, saw the blown leak hatch, fixed it, and you can see the reductions went down immediately. That's a good example of when we're talking about elder techs and operations team stakeholders, this is the type of impact that we can have. And then for operational efficiencies, we've seen time and time again that Qube, if nothing else, is a low-cost insurance policy to stay out of the news. But rather than that, there are other ways of deploying our technology to make very, less capital-intensive decisions on things like facility design. So this is an example of a client that basically said, we want to detect in a couple of basins, whether we have emissions and what we need to do about the facility design. Are there impacts that we can make? You can see this is from June to August of this past year. The impact that was made on emissions reduction by usage of our technology. And so this is an example of a client that had good operations, a good LDAR program, but just needed something to enhance it and kind of fortify what was going on. And you can see in a very short time frame, there was a large emissions reduction. They also were able to use data that we gathered to start correlating an understanding of operational activities and associated performance of emissions when those happen. And so if there's an alarm that goes off, it doesn't necessarily need to be responded to. Someone in the ops team can say, hey, there's a truck unloading, and so you see a huge spike. It's not something we need to respond to, but we need to know about it so we can start baking that understanding in to our emissions profile. And then another really interesting case study that we saw in this example is we had another client actually located in the Permian Basin that was getting ready to do a big facility overhaul. And they wanted to do a whole bunch of design improvements on their facilities. And they were saying, let's go look at our GHG emissions factors and basically say to ourselves, based on those factors, which category is the biggest offender? What's the lowest hanging fruit so that we can go make changes to those and then make a big impact on our emissions reduction? Well, based on those emissions factors, they would have focused on pneumatics and fugitives. In this instance, fugitives for them means like valves and tightened seals, not fugitive emissions. But those are the two categories they would have focused on. So, replace pneumatics, kind of low hanging fruit like that. But what they did instead was actually sent out Qube devices, excuse me, for about 6 months, gathered that data and said, what based on Qube's data is the biggest offender, such that we can look at doing kind of facility improvements. Our data was showing that by and large, tanks was the most massive impact. Followed a very close second or a very far away second by flares. But based on our data and actual measurements, they said to themselves, we actually need to do something about maybe resizing our VRU system or looking at other ways to improve tanks. So they actually did that. They took our data rather than GHG emissions factors, made some investments in facility infrastructure, and then this is the result. So what you can see is they took facility A, which was the original facility that they measured. You can see peak production is month 2, that kind of second black bar and the second green bar. They implemented our learnings and increased their VOU capacity and other things in facility B that they built. And you can see the dramatic impact and reduction of emissions just by doing those facility improvements using findings from us. And so this is a really great insight for facility managers, emissions engineers, ESG folks that are all trying to work together to say, how can we reduce emissions in a non-capital intensive way? And how can we make our money go to the right things that are going to have an impact? And this is a really interesting one too, because in this instance, whether they had a robust LDAR program that was doing quick responses or not, they're simply gathering data and getting an understanding of the highest offenders. And so this was just a really great case study and example of technology that can have kind of secondary benefits. And then last but not least, kind of corporate reporting. So things like Veritas protocols, OGMP 2.0 reporting frameworks, those are starting to become more and more kind of standardized and established. And as that occurs, It creates a really good opportunity to utilize continuous monitoring data in a reconciliation effort. So if you're using GHG emission factors, you might do some drones or flyovers, you might have continuous monitoring, you might have LDAR data. All of that is streams or sources of data that need to be compared to each other to get a really good kind of understanding and tighter threshold to what emissions actually look like. And so a really good gut check for folks in the room is if your continuous monitoring data is greater than your greenhouse gas emissions factors, it's probably a sign of one of two things. Either your facility is not working as intended, or your greenhouse gas emissions factors need to be updated. But either way, they're not reflecting accurately and something's out of whack. Another kind of opposite is if your greenhouse gas emissions factors are greater than what your continuous monitoring data is showing, it probably means you have a good handle on it or it's under control. So that's just something to keep in mind as reconciliation becomes a more and more commonly heard phrase. And for folks whose companies are interested in pursuing certifications or commitments to various kind of climate groups. So something kind of worth mentioning here, back in the 2010s was when the Quad OA and all this kind of regulatory emphasis was placed. This right now and currently established, you've got your, like I said, OGI cameras, AVO inspection, Method 21. Those are the kind of baseline approved approaches to measuring emissions. But over time, a lot of voluntary initiatives and new technology has come into place. And I hate the animation on this slide. But basically you have, continuous monitoring, fence line monitoring, you have drones, you have cameras, you have satellites, you have airplane flyovers, and you will hear probably every technology in the industry. And if they're not saying it, it's probably not, they're not telling the truth, but there is no one-stop shop. There is no magic silver bullet. And we're the first to say that. You're not going to put continuous monitoring technology on 2,000 miles of pipeline, right? That doesn't make any sense. But you are going to put it on your well pads, your gathering facilities, your tank batteries, things like that. Pipelines may be better served with flyovers or drones or other kind of intermittent measurements as frequently as you can possibly get them. But anyways, the point is that there is no one silver bullet and there will be a profile of technologies that you use. But we do believe that continuous monitoring is kind of a very core, low-cost way of getting continuous and empirical data on your site. As that technology evolves and as proposed regulations evolve, you'll start to see an opportunity or innovation for these voluntary initiatives to become either approved as an alternative to regulatory or used in combination with regulatory requirements. And so, so a lot of times what you'll see with companies is they're going to do what's necessary to stay in compliance with EPA, with Quad OA, Quad OB, Quad OC, but they're going above and beyond. They're doing quite a few more LDAR measurements than necessary. They're kind of trying to stay ahead of the game. The idea is that you can use technology like ours as an alternative to regulatory if and when approved, or you can use it as an enhancement with a voluntary initiative to be able to use it to fortify your data. Ultimately, I think that there will be a place for continuous monitoring as kind of a formal, accepted way of doing things. But as that evolves, I do want to emphasize that it can and should be used prior to being regulated as a voluntary kind of low-cost way of being able to get a good handle and insight into emissions. And then last but not least, Qube has had experience, like I said, with various regulatory bodies kind of submitting applications and doing approvals. You can see kind of the bullet points on the left. I don't have to read them to you, but all of those requirements to be able to submit a regulatory application are very similar to requirements to submit certifications. So if you're looking at responsibly sourced gas, with various, MIQ or EO 100 or various certifying bodies, the point of this slide is just to simply say we've gotten experience with regulatory and certifying bodies. And so not that we're a consulting firm, but we can help out. And we have been successful in the past with what we've put forward. One last thing I'll close with is it is important for the regulatory stuff to understand that the technology itself is not going to get you regulatory approval. It's going to be how you administer that technology, what kind of framework and process internally is in place to show that it can make an initial impact, but continue to make an impact. So it's a matter of not just what technology you're using, but how you're using it to be able to get approved. And so with that, I think that I might have even done the record like speed finish. I don't know what time it is. Does anyone know?
3:43.
What did we start at? 3:15? Not bad. Okay, thank you so much and open for questions. Yeah,
You mentioned the speed information earlier. Where does your technology come in?
so we place an anemometer on every single device, and that anemometer is measuring wind speed and direction. And that we kind of think is a differentiator. So depending on the technology structure, sometimes folks will put an anemometer, some kind of meteorological data measurement in the center of their deployment. And that's fine, but what it assumes is uniform wind distribution, which if you're anywhere with bluff bodies or lots of pieces of equipment or hills in the background, you know that wind tends to swirl. Wind can change depending on the size and profile and kind of acreage almost of a site. And so wind can be super fast up here and super slow down here and blowing in opposite directions just about. And so it's really important to have that kind of granular level of wind measurement. Because it helps our algorithm understand better quantification and better localization data. Yeah.
What would you say that the differentiator is between Qube solution and some of the other competitors out there?
So that one main differentiator is our anemometers. Something else I think is a differentiator, and I'll kind of speak bluntly here. The hardware itself will probably at some point become somewhat commoditized. Every company in this space is trying to drive down the hardware costs as much as possible. The differentiators, though, will come with how you're able to use the data in your algorithm, how advanced is it, and then what's the experience with you as a vendor. And so we've really tried to emphasize, once we deploy the devices to you, it's not, here's the devices, call us if anything happens, good luck. We have a big and growing customer success group whose job it is to make sure that you know how to interpret the data, that you know how to set up the alarms, that you're forcing the conversation if you need to be the one to do it between the ops folks and the ESG folks and the corporate folks. And that's been huge. And that kind of helps companies stick with data like that. And then we can become advocates a bit if we need to for the ops folks that want to be able to have a voice in how it's administered. But the algorithm is really going to be something that you'll start to see companies, I think, pull ahead of others when it comes to how good is your localization, how good is your quantification, are we getting any false alarms? Do you send this out to chase ghosts? And our experience, we have 3,000 devices deployed from last year, and we're on track to at least double that this year. If we have an alarm going off or if we're sensing something, something's happening. So it's a matter of kind of finding out where it is.
Do you sell them or rent them or lease them?
Good question. We sell them. So it's the idea is that you sell the hardware and then you have an ongoing recurring monitoring fee for dashboard access.
Can you share that information? What's the price?
We can talk price. Whatever. We keep it very simple. The current list price, and I'll caveat that, is $2,000 for device and then $80 per month for monitoring fees. A massive caveat for those in the room, that is our list price. Things become very friendly with bulk volume discounts because we have an understanding that companies have to look at this from an expansion or scalability perspective. And so if we have an understanding of kind of larger scale orders, we manufacture and assemble in-house ourselves. So we can go and make bulk orders and get that discount ourselves and turn around and pass it along. So the better that we can have a conversation on timeline for ordering larger kind of outputs, the better that conversation gets.
Hello. One on the non. The $80 a month, is it per device or is it per location or?
Per device.
Per device.
Yeah. And so our, what happens is our algorithm is performing calculations constantly. Our dashboard is unlimited users. We're working to make sure that you can have various user settings and protections. The data is yours. It's exportable through API or standard kind of CSV export or Excel download. So you have uninhibited access to the platform kind of forever and ever with that cost.
Does it integrate with SCADA systems or is it solely?
So SCADA systems themselves tend to be very, it's hard to, you can't import anything within a SCADA system. You can export that SCADA data and have it combined with other data elsewhere. And so, yes, that's why we designed the API capabilities, because inevitably, like, interacting with our dashboard is what you're going to do specifically for an emission when it goes off, or for you to get a good understanding of what's happening in the field and why an alarm was going off and things like that. But if you're wanting to look at trend data, you want that data exported and you want it to be combined with something else.
Yeah, your dashboard's more for smaller organizations that don't have a team of data scientists. looking at it.
Yes, depending on the kind of maturation level or the saturation of dashboards within a company,
Yeah.
big or small, they might say, we have 700 dashboards that we look at. We just want one. So we're not even going to use anyone else, and we're not going to use you unless your data can go into this dashboard, because we can't look at one more.
So the $80 really like that. It's the fee for the API.
Yeah,
Yeah.
well, it's a lot of things, but yes, if you want to
Sure,
boil
sure,
it together.
right.
Yeah, and so, depending on the companies, they look at it and think, I have a huge, obviously, capitalization of hardware year one, but then my recurring fees, which my operations teams care about keeping LOE low, those are much lower from years two forward.
Is that negotiable as well, or just a hardware price?
Well, I know
Flexibility.
everything's negotiable. Let's have a conversation.
So I've seen a few presentations about what's the difference between this and like a line cap, like FTIR line cap kind of monitoring?
An FTR line path.
Path line site,
Oh,
next one. Right?
yeah, so like,
Next one.
it's a bit like lasers and cameras type of thing.
Kind of, yeah.
So depending on the geographical kind of structure of where your site or your facilities are, depending on the time of day, depending on if there's a lot of debris in the air, oftentimes technologies like that can struggle with around the clock continuous monitoring. And then I'm honestly not sure of the frequency with which they do monitoring. I know sometimes they can kind of go around and take snapshots at a semi-frequent pace, but it's not at, the open question is, what is continuous? What is it defined as? And that was something that people struggled with in the EPA regulatory proposal was, what does continuous mean? Is it once a day instead of, once a quarter? Is it once an hour? Is it every 1 second? What defines continuous? Other questions? Yes.
Speaking on that geographical location, so where do you have these deployed? Like what areas do you have? I don't know if you mentioned that.
Yeah, so we have them in every single basin in the US. We have a higher density of deployments in certain basins than others. The Permian is a very big deployment area of ours, and that's because it was not intentionally designed to not produce gas. Up in the Northeast, you see much cleaner sites and facilities and much lower kind of alarm thresholds with our deployments because they were designed to produce gas and not leak it. That was a byproduct in the Permian initially.
And with the deployments, what issues have you found with like weather? Have you found any like alarming things that you guys are working on?
I would say like a couple of years ago, when we were kind of fresh doing deployments, we had to get right how to fortify deploying the devices, like what kind of a stand worked well, so that a big, huge gust of wind wouldn't knock them over. That was a couple of years ago, so we've since learned, and that was kind of the only thing. You have the occasional, I think someone mentioned it earlier, stolen solar panel. But yeah, permanently borrowed solar panel, and those types of things can't be avoided. But in terms of weather, every new kind of country or area that we go to, we're kind of evolving. And I think we're at a point now for the last year or so where our deployments are, if they're there, they're there. They've seen some North Dakota winters, which I feel like get colder and they're harsher than Canada even. They've seen some crazy windstorms, basically next to tornadoes in the Permian. DJ Basin, same thing.
And you haven't had any issues with like, let's say someone borrowed a solar panel and then you had to go to battery.
Yeah.
Those batteries with
That's
That-
what-
extreme.
yeah, that's my question.
Yeah, so two things on that. The batteries last for a certain amount of time without being recharged with a solar panel. That's just simply the way it is, and that's the way it's designed. So we have, to kind of combat that, we have two things. One, all of our devices are designed modularly, so if that happens, you're not going, our solar panel got stolen, so we need a whole new device. You're saying, hey, let's just replace a solar panel and then this device keeps going and it's good to go. And then secondly to that, we have a health dashboard. And so the idea is if you're talking about hundreds of devices that you have deployed, the deployment of a device does not necessarily mean that a device is up, running, transmitting data. And so we have a health dashboard where you can actually look at the devices and understand that they are transmitting data. Here's the last time they did. The signal strength is strong. The battery life looks good. The battery life hasn't degraded over the last 24 hours and things like that. And so if you kind of look at it and see, right now it's not on a proactive notification basis. So you go and kind of look at it. I'm sure that will evolve over time. That's definitely something on our product roadmap. But if you look at a device and the battery life is red, it's kind of a traffic light status, and it says, 20%, and yesterday it was at 98%. Probably something's going on, like it's covered in snow or sand, and so the next time someone goes out, dust it off, and then you're good to go. If it's at 0, something's gone wrong with it completely. So that data allows you to sort of troubleshoot what's happened without you just going weeks and weeks with no data transmitting, but having no idea that you're monitoring but not monitoring.
How are you transferring your data from the device to your cloud? Is it through cellular, satellite?
Yeah, so network connectivity, LTE network connectivity.
Okay, so what if you have no cellular at all?
So if you we typically use AT&T, Verizon is kind of the backup. If those are not present, oftentimes a client themselves, especially on sites with higher production volumes, will have their own Wi-Fi setup. And so we can plug into that. That's the, less than ideal situation, because if they have single sign-on, things like that, you got to make sure those devices are logging onto the Wi-Fi security the same way anything else would. But if there's just no Wi-Fi period, we can't monitor it right now. We've looked into kind of Starlink and satellite stuff, and those do get the job done, but they drive the cost up so high that it kind of is a non-starter for companies. And we do think over time, in terms of the percentage of sites that don't have access to Wi-Fi or connectivity at all, cellular companies are making sure it's better. Companies are feeling pressured to, and for safety reasons, to get Wi-Fi out there. And so I think that's a problem that will catch up with the solution before we can make it cost effective, looking at Starlink or something like that. Be brutal honest. If it's not there, we can't do it.
Is it stored internally then? So can we still have a monitoring device there, stores it within the memory, like an edge computer there?
Yeah,
Someone can daily pull it or whatever. I mean, is there that option also, or is it just pretty much you're not on the list at all to be able to?
we do have some edge computing and storage on it. I actually don't know off the top of my head how long that storage stays. I can get that answer, but I'm not sure how long the buffer storage kind of lasts before it reconnects to. Yeah. These are really good questions. Keep going. Yeah.
Off of that question.
Yeah.
If you're seeing that it's kind of, reaching the end of the data,
Mhm.
The max data, is the efficiency and effectiveness still the same, or do you see a decline?
That's part of the, are you talking about the data itself, like data storage itself?
Well, no, so if
Effective the whole entire system.
Oh, like
starts to, it's not as good anymore.
Yeah, one camera's down, but 3 are left up.
Yeah, so our algorithm is built to be able to say, hey, if you have, it's not arbitrary, but in the sense that if we have a site that we're deploying to, and we decided that 4 devices is the ideal number of devices to get good coverage. If one of those devices goes down, it can be quarantined, and the algorithm updates to say, okay, now the data that we're getting will only be with 3 devices. And so maybe the localization is not as good as it could be, but you're still monitoring it. You're still able to understand and detect if there's emissions and things like that. So it's not like an all or nothing situation where it works as a whole. And that's been, key when you have your little random solar panels out for a couple days. That's okay. Your site is still being monitored. We can get to that and then we're up and running in a more ideal structure.
Is that fairly common though, to not have all your cameras working at the same time?
No, it certainly happens from time to time. I think inevitably with hardware, you'll see stuff here and there, but it's more the exception than the rule. But companies definitely want to be able to see that dashboard, to see that for themselves. Yeah. Other questions? The side room's super quiet, so I'm just gonna stare until you ask. Yeah,
Yeah.
awesome. What time is it?
58.
Okay,
58.
I think we're good. Any last one?
No, thank you.
Yeah, thank you. Appreciate it.